we introduce our method, LayerComposer. The motivation of this work originates from commercial image editing software like Photoshop, where users have more control over the design process. One of the current issues existing methods face is limited interactions, where users have very minimal control and interactions over the design and generation process. Users in this case are passive prompters, not active directors for their own creative designs. Another issue is the scalability bottleneck. Once we scale up to personalize more human subjects, we run into problems of O(n) complexity growth, where existing methods suffer as the number of subjects increases. To this end, we introduce LayerComposer. Our method starts with a canvas with an optional background. Then the user is free to place and resize their personalized subjects to achieve interactive personalization. Secondly, instead of using the traditional naive collage input, we introduce our novel layered canvas input representation, where each of our personalized subjects is represented by a distinct individual layer. Our layered canvas representation allows us to efficiently handle occlusion cases. Last but not the least, we also introduce selective locking, where our locked layers in red are maximally preserved to remain the same as input except for minimal lighting and shading adjustments, while our unlocked layers in green are adjusted to the context. We sample our data from series of samples containing the same human subjects with different poses and backgrounds. We randomly assign one to be the target while the remaining images become the source images. During lock-and-aware sampling, our locked red layers are directly sampled from the target, while the unlocked green layers are sampled from the source images. Our method retrieves masked tokens from VAE, where the first dimension is a binary locking flag, where 0 means locked, while non-zero means unlocked. Transparent latent pruning selectively retains tokens from valid spatial locations, which are then fused and sent into diffusion for generation. We now demonstrate the qualitative results from LayerComposer. We have 3 benchmark personalization settings. The first one is single person or 1P, then 2 person or 2P, and lastly, the challenging and relevant 4 person or 4P personalization task. We first benchmark on 4P, and we only compare to editing-based methods here as standard personalization approaches do not work well in 4P due to limited scalability. Evidently, our LayerComposer generates images with higher image quality, enhanced ID preservation, better following spatial layout, and superior occlusion handling. For 2P personalization, we also compare LayerComposer against the state-of-the-art personalization methods. Consistently, our method yields higher image quality and also enhanced ID preservation. Last but not least, for the 1P personalization task, we compare LayerComposer against leading 1P approaches. Reliably, our method again generates images with higher quality and also stronger adherence to text prompts. We also conduct an ablation study to examine the necessity and effectiveness of our locking mechanism and our layered canvas input representation. Ultimately, we reach to a conclusion to claim that our lock layers are preserved only with necessary lighting adjustments, while the unlocked layers are fully adapted. Occlusion can be effectively handled by the layered canvas. We thank your time for reading our paper.